I don't know if you're done yet, but I'm gonna give you a nudge along the way if you're not. And also to help you out with some of the algebra, just to make sure your numbers are correct. Okay. So what's going on? Firstly, this line here. Okay, very simple, but don't neglect it. Okay. The primary reason why is because when you're going from words to equations, okay, I find it a lot easier to make problems, introduce problems when I don't have this line, okay? Because this, I'm literally reading off the question, okay? The distance from P to A is double the distance from P to B, okay? Sometimes you put two on the wrong side, and all the algebra will come out, but you just have the wrong locus, okay? So just be careful. So that's why my 2 appears here. And worth highlighting is the 2 doesn't stay a 2, okay? Get some bright colors and point to this 4, okay? Because again, one of the challenges with this kind of topic is that everything will look okay, and you won't work out till later that there's dramatic problems, okay? And maybe you won't work it out because the numbers look okay, and you just didn't multiply by the right thing. Okay. Now, when you get down to here, some of you might be tempted to stop, okay? In a sense, because I didn't say it, right? I didn't specify what form the equation should be. Now, question, if they don't specify, what form would you default to? Probably general form, right? Because general, it's just, I don't know, that's the most normal
general
form. Yeah, exactly, right? So remember, for each different kind of function, or relation actually, you've got a different general form. So for a straight line, what's the general form? Yep. Everything on the one side equals to 0, right? Just to be nitpicky, your A, B, and C should be whole numbers, and your A should be positive. Okay? For a parabola, what's the general form? So all of the terms, right, all the coefficients match the straight line, but instead, you've got these powers going down. Okay. What other general forms do you know?
Circle.
Okay. Circle.
I win. I'm right.
Okay. That'll be on video. What do we got here? We want to have a form which makes the geometric features of the circle obvious, namely its center and its radius. Okay. So you could put it. You might have seen this form. You've got x minus k squared, y minus h squared. To be honest, I don't know why they're k and h. By the way, if you know why, if you've seen why, then you know. I don't know why it's not just a and b. Anyway, this is called the radius squared. Now let's have a think about this. These are our general sorts of equations, right? Which is this closest to? That's a circle, right? Can you see it's got all the bits for the circle? Just hasn't been factorized nice and neatly. Okay? So let's do that. Factorizing requires that most archaic of skills, completing the square. Okay? Maybe you forgot how to do this when we're solving quadratics. You might have thought, why do we have to complete the square? It's a very inefficient way of doing things. You can factorize or you can use the formula, right? They're both better than completing the square, they're faster. The reason why we kept teaching you it is because of these, just because of circles. Right? So let's do it. To complete the square, the first thing you want to do is get all of your square terms, your x squared and your y squared. You want them to be monic, right? So you want them to not be 3 but 1. Okay? So I'm going to divide everything through by 3. That's going to give me x squared plus this weird looking fraction. Okay, are you content with that so far? Now what I'll do, just to make it easier for my brain, is to match up the parts that relate to each other. Okay, just so it makes it easier for me to factorize. While I'm at it, I may as well also take this 10 over 3 and move it to the other side. Why? Eventually, this 10 over 3, or a negative 10 over 3 over there, right, is going to become a part of this r squared. Right? I don't want it over here, so I'm going to boot it over there. Okay, done. Now, how do I complete the square? There are 2 steps to it, right? I'm adding stuff to these 2 different things to make them into squares. That's why it's called completely square, right? What do I have to add? Look at this. Which number am I paying attention to? Which number? The 10 over 3, right? So look at it. You've got to do 2 things. You've got to halve it, and then you've got to square it. Okay, halve it, square it, and that'll tell you what you have to add. Okay, so when I halve it, I get 10 on 6, 5 on 3. Okay, and then I have to square that, which gives me 25 over 9. Right? Okay, now since I added 25 on 9 on here, to keep it balanced, I have to add it over this side too. Okay, now conveniently, because I chose some okay numbers, right, it's the same thing here. Even though it's negative, I halve it, I'll get negative 5 on 3, but when I square it, it all comes out in the wash. Okay, so it's this and another one. So I'm just going to multiply this by 2. Alright. Now, what does that give us? Now that I've got this 25 on 9, right, added onto both of these, I can say x squared plus 10 on 3x plus 25 on 9. This thing is a square, and I can factorize it, and it'll tell me the center. Okay? This is also a square. Oops. Can someone tell me what the radius squared is going to be? What value do we get? Some weird fraction, right? 20. Oh!
9.
Okay. I also need to actually finish factorizing these so I can get it into this form. Okay. So what are we going to do? Remember when we halved it and then squared it, right? Well, this is going to be x plus the halved part, right? Because when you square it, that's what ends up with this. Okay. So I just remember that 5 on 3 I had before, squared.
No, it's the same thing.
And that one's negative. Okay. There's my center. You can read it off there. And I guess here, 20 or 9, how would you rewrite that? Well, you want to put that as the square of the square root of that, right? So my radius is the square root of 20 over 9. Okay. And that's a bit messy, but you can work out what that's going to look like. So this is a circle. So that's interesting, right? Just by doubling this distance, you went from a line to a circle.